Good morning. Here's another example of inductive reasoning to find a pattern, and then we will do the deductive reasoning when we do the algebraic proof. Your job here is to pick any counting number that you like. You will add 7 to it. You'll multiply that result by 4, then subtract 20. Then take that answer and divide by 2. Take that answer and subtract 4. I'm going to pick my counting numbers as 3, 6, and 10, but you can pick any counting numbers that you like. I encourage you to pause the video, fill out your table, and see what you think the pattern is from your beginning counting number that you select to the very ending result. Here are my results. When I started with 3, I ended up at 6. When I started with 6, I ended up at 12. And when I started with 10, I ended up with 20. And so I think, based on the examples that I did, that I take my original counting number and I double it to get my ending number. So what happens to the original number? It doubles. So that is our guess based on inductive reasoning. To prove this, we can come through and do all of the work algebraically and see what happens. When we pick any counting number algebraically, we would pick something like n or x. I'm going to use n, and then add 7, means we would write n plus 7. Multiply that quantity by 4, so 4 times the quantity n plus 7. And you could leave it like this right now, or you can do a little bit of simplification here. Let's do a little distribution. You would get 4n plus 28 as a simplified version right there. Then you'll take that answer and subtract 20. Let's combine like terms. We had 4n plus 28 minus 20, and that will simplify to 4n plus 8. The next part of our rule says to take the previous answer and divide by 2. We'll get the quantity 4n plus 8, all divided by 2. We'll get 2 divisions here, kind of like we did in the last example. This will give us 2n plus 4. And the final step says, take your previous answer and subtract 4. Our previous answer was 2n plus 4. When we subtract 4 and collect like terms, we end up with a final result of 2n. This shows us that when we start with n, the final result is 2n, which is doubling. So we have done a deductive proof of what happens to any counting number, and in fact any number that we select, and it verifies our inductive reasoning when we thought that our quantity should double from beginning to end.